Okay, now we're going to do our practice quiz for polar graphs and all that in this 6.4 to 6.6 section. The sheet I'm doing, you have a PDF of this. It's Precal C, Quizzy Poo, practice. And it does say up in the top corner, no calculator. In the beginning, this was a no calculator exercise, but then I added some stuff to it. So we will be using a calculator for it. So here we go. So the first one, you have the classical curve shapes, and they are freehand drawn, so please don't get too crazy. I mean, mad at me or make fun of me. I'm not the best artist in the world. Here they are. And we're going to name the 4 classical curves. So we're just going to give the names of the curves. So hopefully you have your notes handy because we went through all the classical curves. This one is the Lemniscate. And I help myself remember it because if you, there's a C there. If you say the word wrong, if you say Lemniscate, then that reminds you it is a figure 8. So the Lemniscate, that's C-A, Lemniscate is your figure 8. This guy that looks kind of like a flower, that's your rose. And of course we talked about, and there'll be some problems down here further on the paper where we review some of the rules about how many leaves they have and so on. This is of course a spiral. With no arrows on there, there's no way of knowing which way this thing's spinning. So it's just a spiral. We're just listing the classical curves. And this guy is a limacon. So you are required to know the names of the classical curves. So this would be good for you to be taking some good notes on this old quiz so that you'll be ready to do that if called upon. Okay. All right, number 2 says, consider this guy. Now, I know he's a limacon because if you remember from the other day, if the equation has an add or a subtract in it, an addition or a subtraction, if there's a plus or a minus here, it's a limacon. This is a limacon. Now, the question says, is it a cardioid though? Is it a cardioid? Well, you remember from the notes we took the other day that this is not a cardioid. And it's not a cardioid because these 2 numbers are not the same. So the reason it says, is it a cardioid? No. Why or why not? 4 and 8 are not the same number. In order to be a cardioid, these 2 numbers will match. They don't. So that is not a cardioid. Okay. Next. Where would you plot -2, 100 degrees? Now, I didn't give you a grid. You don't actually have to plot this. The issue is that when the radius, when your R value is negative, you can't plot it. So we have to make the R value positive. This is R, this is theta. We got to make the R value positive. And then you remember what that does to the angle? When you make R positive, your angle changes by 180 degrees. So in other words, you go the opposite direction. Instead of going forward, you go backward. So instead of going 100, we're going to go 280. because that is exactly the opposite direction. If you think about it, the opposite direction is 180 degrees different. So instead of going 100, we're going to go 280. So when you change the sign on your R, your angle changes by 180 degrees. So this is the answer to number 3. All right, now number 4 says we have a rose. This is a rose. I know it's a rose because if it were a spiral, it wouldn't have this. If it were a lemniscate, that would be squared. And if it were a limousin, it would have a plus or a minus in there. It didn't have any of those things, so it is a rose. Now, I want to know how many leaves it has. How many leaves it has. Now, you'll remember that in the equation of a rose, this number gives you the length of the leaves. So the length of the leaves is 4. So the leaves are 4 units long. Now that isn't the question, I'm just doing that for review. This question wants to know, how many leaves does it have? That's controlled by this number. Remember, it's a little bit tricky. If this number is odd, which it is, that's how many leaves there are. So there are 5 leaves. But remember, if this number is even, like if that had been a 6, then there are twice that many leaves. So this is the number right here that controls how many leaves there are. If it's odd, it is that number. If it's even, it's twice that number. So the answer to number 4 is, how many leaves does it have? It has 5. The next one is a lemniscate. When you say, Mrs. Ford, how do you know it's a lemniscate? I want to remind you, if it's got a squared, it's a lemniscate. Lemniscate, figure 8. So if I were going to graph this thing, it would be some kind of figure 8. Either slanted, up and down, sideways, some kind of figure 8. And I want to know, okay, so it's going to be some kind of figure 8. I want to know how long these leaves are. How long are they? Well, remember, this number right here told me the length of the leaves in the rose. The problem is that's a squared. So if I were to square root both sides, then that number wouldn't be a 9. It would be a 3. The square root of 9, 3. So how long are the leaves? They are 3 units. If that had been a 16, they would be 4 units. Square root both sides, and it operates just like a rose. Just like a rose. This number right here tells you how long they are. That's a squared, though, so you got to square root it, and that gives you a 3. Okay. So now the next one, this is number 6, says which of these is the equation of a rose? So we got that one. We got this one. And we've got this one. And we want to know which one of those is a rose. Now, I want you to stop a minute. Take a look at this first one right here. Do you see how it does not have a sine or a cosine in it? This is a spiral. This is not a rose. It is a spiral. If you don't have a sine or a cosine, you're a spiral. See this one, how it has that plus sign right there? That means that's a lemniscate. If you have an add or a subtract in the middle of your problem like that, that's a lemniscate. So guess which one is the rose? This guy right here is the rose. Now, before we go on, it doesn't ask me about it, but before we go on, let's review a little bit. This rose, how long are his leaves? His leaves are 2 units long. And how many leaves? What are the number of leaves? Well, again, if that number's odd, that's how many you've got. So this is a 9-leaved rose. If you were going to graph that on your calculator, you would get a nice little rose that has 9 leaves. All right, now we're ready for number 7. Name the 2 types of spirals. Which is which? Well, we have the spiral of Archimedes, and we have the hyperbolic spiral. These are the 2 kinds of spirals that we are studying. Now, which is which? Notice it doesn't ask me to write an equation for them, although you could using your notes. It just says which is which. So remember, the spiral of Archimedes starts at the pole and spins out like this. That's your spiral of Archimedes. Your hyperbolic spiral starts out here and spins in like this. That is the difference between the 2 kinds of spirals. So the spiral of Archimedes starts in and spins out. And the hyperbolic spiral starts out and spins in. For your information, an example of a spiral of Archimedes would be r equals 2 theta. And the hyperbolic spiral would be r equals 2 over theta. So that's the difference in the equations. You need to know what the names are, and you need to know which is which. But this is just extra information, so you can tell them apart if you wish. Okay, number 8 refers us back to number 6 and says which is the equation of a spiral. Well, we already answered that. Back in number 6, this is the spiral equation. Happens to be a hyperbolic spiral, but that's the spiral equation, and we know that. I'm doing number 8 now, which refers me back to number 6. This is a spiral because look at the equation. There is no sine or cosine. If you do not have a sine or cosine in your equation, then you are a spiral. Okay, so now we've snuck in 8.5. So 8.5 says find polar coordinates for 3, -6. Now, we're finding polar coordinates, which means we have to find an r and a theta that goes with this x and this y. Okay? Now, this is easy to do. We've done a lot of this in our other notes, but here's what you have to do. You have to draw a picture of 3, -6, so it's going to look like this. Over 3, down 6, xy, xy. This is going to be our r. Now, we're going to find this angle, but our actual theta is going to be this one. Okay, so how do we find R? Well, the same way we've been doing it. Square the first number, square the second number, add them together, and take the square root. So that's going to be the square root of 45, which breaks down into 3 root 5. So your R value is 3 root 5. Remember, 45 breaks down into 3 root 5. Now, to find the angle in here, I know that the tangent of that angle is 6 over 3, or 2. So the tangent of that angle is 2, which means the angle can be found by second tangenting 2. Since that's hooked to the A, I got to do second. So second tangent 2. And that gives me 63.43. So this angle right here is 63.43. Now that is not theta. Theta is the red angle, the big red angle. So how am I going to figure out the big red angle? All the way around is 360. I didn't make it all the way around. I stopped with 63 to go. So we'll just do 360 minus 63.43. And our big red angle is 296.57. And those are the polar coordinates for the ordered pair 3, -6. Remember, polar coordinates, you're just finding R and theta. Well, guess what? We get to do another one. There's another one in there. So we're going to do the same exact thing. So you get to practice again. You do the same exact thing. Okay. So this time we have -1, -3. Okay, so this is our x and our y. We want to find the r and the theta that go with that. So let's draw a picture of -1, -3. There's my butterfly bow tie. Mrs. Ford, how did you know to put it there? Well, remember, this is your x and your y. So we got to go left 1 and down 3. We're going to plot the point, -1, -3. So it's right here. So there's my butterfly bow tie for 1, 3. Okay, so I need r. To find r, I square the first one, 1. Square the second one, 9. Add them up and take the square root. So my radius is √10. Now I need to find my angle in the triangle at the origin, right there, that angle. So I know that the tangent of that angle equals 3 over 1, or 3. The tangent of that angle equals opposite over adjacent. So I'll go to my calculator, and I will second tangent 3 over 1, or second tangent 3. And that angle is 71.57. I keep saying it over and over again. You have to be so careful. This is theta. Theta is the angle in standard position. It has to start over here and come all the way around. So that's 180 plus 71.57. 180 plus 71.57. So 251.57. And that is the theta. Those are your polar coordinates for the ordered pair, -1, -3. Okay. Now we're going to do a little bit of freehand sketching, it looks like. So on to number 9. Number 9 says, freehand limousin. Now, again, you can draw this many, many different ways, but the limousin, remember, is the lima bean thing. So there is a freehand example of a limousin. It can be situated any way you want. So you could have one that was, you could even have one like this with no loop. That would be a cardioid limousin. Those are freehand limoussins. Now 10 says, draw a freehand lemniscate. Lemniscate figure 8. So again, you can have it drawn this way, you can have it drawn sideways, you can have it drawn diagonally. Any kind of figure 8 would be a freehand lemniscate. 11 says R equals 8 cosine 12 theta. And we want to know how many leaves it has. So remember, this is a rose. There's no squared, no plus or minus, and there is a cosine. So this is a rose. It can't be a limousin, can't be a lemniscate, can't be a spiral, so it's a rose. This tells me the leaves are 8 units long. So if I were going to graph this on my calculator, I'd have to make sure that my screen was big enough to accommodate 8 units long. And then this number right here tells me how many there are. If that number is odd, that's how many there are. But if that number is even, there's double that. So this thing would have 24 leaves. This rose would have 24 leaves. Because if that number is even, there's twice that many leaves. Now, number 12 is a trick question. Number 12 says, how many leaves does that have? And the answer is none. It's a spiral. How do I know it's a spiral? Because that equation does not have a sine or cosine. It is not a rose. It is not a lemniscate. It is a spiral because it does not have a sine or cosine. Very, very tricky. That happens to be an Archimedean spiral, if you care to know that. But the answer to the question is no. No leaves. None at all. All right, one more. It's a two-parter, but number 13 says we have 3, 120, and we have 5, 197. These are two separate problems. I'm just writing them both down at the same time. And we are going to find rectangular coordinates. That means we're going to find an x and a y for each of these. This is r, this is theta. These are polar coordinates. We need to find the rectangular coordinates. Well, this is what's in your notes, hopefully highlighted, underlined, whatever, marked big time. X equals r cosine theta, and y equals r sine theta. That needs to be in your notes. x equals r cosine theta, y equals r sine theta. So anytime you are finding an x and a y, x is going to be 3 cosine, y is going to be 3 sine. So 3 cosine 120 is negative 1.5 for x. 3 sine 120 is 2.60 for y. So there are my rectangular coordinates. This is going to be exactly the same thing, only this r and theta are 5 and 197. So 5 cosine 197, 5 sine 197. Negative 4.78 is my x. And negative 1.46 is my y. I cannot hammer home enough. You're probably sick of hearing me say it because I keep saying it over and over again. If you want to find x and y, x equals r cosine theta, y equals r sine theta. It is that simple. It's a matter of just typing it in on the calculator. 3 cosine 120, 3 sine 120. 5 cosine 197, 5 sine 197. That is how we find rectangular coordinates. All right, that's it for that practice quiz. Good job.